Let us now discuss the dispersion analysis by a thin angle prism. As we already studied that if there is a thin angle prism which is having a prism angle A and it is having its refractive index mu, then for any light which incident at near normal incidence, then its deviation angle we write as A multiplied by mu minus 1. Now let us consider if a white light is incident onto the prism, and in this situation for various colors the refractive index of the prism material for the white light would be different, and say here we consider three prominent colors: violet, red and yellow. So for violet color, say its refractive index is mu v, for red color it is mu r, and for yellow color it is mu y. Yellow I am taking because yellow color is considered as the mean of violet and red color, and the yellow light out of all colors and white light is considered to be following the mean path of the white light. Now in this situation, as we know, as soon as the light ray goes from air to the denser medium, the light is dispersed into colors, and due to second refraction the colors are separated, and finally it will produce a diverging beam of light. And as we know, violet is having highest refractive index, so bending of light will be maximum in case of violet color. So in this situation, this will be violet, this will be red, and the mean path we consider to be followed by the yellow color. Now in this situation, if in front of this diverging beam, if we place a screen, as we already studied that it produces a spectrum on the screen. Now in this situation, from the original direction, which was the direction of incident light, if we talk about the deviation produced in different colors, say if this deviation is delta R, the deviation of red light, this is the deviation of yellow light, delta Y, and this is the deviation of violet light, which is delta V. Here we can directly write delta R to be equals to A multiplied by mu R minus 1. Delta Y will be A multiplied by mu Y minus 1. And delta violet will be A multiplied by mu V minus 1. Now in this situation, if we talk about the mean deviation of light, then mean deviation of light is considered as a deviation of yellow light, which is written as delta y, that is A multiplied by mu y minus 1. And if we talk about another important term which we term as angular dispersion, angular dispersion is the angle in which the light ray is finally diverging, or it is the angle between the red light and violet light in the emergent beam. So if this angle is written as d, then angular dispersion d can be written as, it is simply the difference in the deviation angles of violet and red light. So this will be delta v minus delta r. If we substitute the values of delta v and delta r over here, this will be A multiplied by mu v minus 1 minus A multiplied by mu r minus 1. On simplifying, we are getting the value of angular dispersion as A multiplied by mu v minus mu r. Here you can also directly calculate the dispersive power of prism material. Here average dispersive power of material can be given as omega. Here we can write it d divided by delta y, as d is the angular dispersion and delta y is the mean deviation of light. So it can be written as, if we divide the two equations 1 and 2, then the ratio of 2 by 1, this will give us mu v minus mu r divided by mu y minus 1. This is the way how we calculate, and this approximately equals to d mu by mu minus 1, as here you can see the difference of violet and red refractive index we can write as variation in refractive index divided by mean refractive index minus 1, which is already the expression we have studied in the previous section. So this is the expression we use for average dispersive power of a prism material if we are given with the refractive index for violet, red and yellow light. Sometimes even if yellow light refractive index is not given, it can be taken as average of red and violet color.